Hello, my name is Aiden Smith. I'm going to be an astrophysics major once I'm done with my basic credits here at Collin. And today I'm going to be talking to you about black holes. So we are going to go over three different talking points about black holes. First off, what they are. Second of all, how they're formed. And third of all, just some interesting facts about them. So first of all, what they are. Black holes are interstellar bodies throughout the universe that have an extremely strong gravitational field. So, what I mean by extremely strong gravitational field is that they are so strong that not even light, and we all know that light is the fastest thing in the universe, cannot even escape its grasp. Every single astronomical body has a force of gravity affecting them. So, taking the solar system, for example, every single body, planet, asteroid, comet, stuff like that, every single one of those objects orbits around the sun because of the sun's astronomical gravity. Every single star, every single planet, every single body has a force of gravity acting upon it. So black holes have a gravity so strong that they do have an orbit, but they have something called the Schwarzschild radius. Keep that name in mind. I'm going to go over it later. The Schwarzschild radius. So, what this is the radius of the event horizon. The event horizon is the point in which nothing can escape its grasp. So, the point where you start falling into the black hole and there's absolutely nothing you can do to escape it. Not even light can escape that. Black holes also have an infinite density. So, what this means is essentially that they are so infinitely dense that we cannot perceive any sort of form. All we see is a little black hole, essentially. That's pretty much why they're called it. Their mass is also extreme. So I'm going to go over why their mass is so extreme in just a second here when I go over how they're formed. But just keep in mind that the density, imagine if you took the entire Earth and shrunk it down to the size of a marble, keeping the same mass. So we have this tiny, 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 tiny little marble with the mass of the entire Earth. That's essentially that it gives you kind of an idea of how dense these bodies are. Otherwise, though, other than the extreme gravity, the infinite density, and extreme mass, they are pretty much featureless. Those are the only three things that really make up a black hole. So going on to the second part of this is how they're formed. So to go over how they're formed, we have to go over the life cycle of a star. So kind of skipping a little bit of the beginning stages of a star, we mainly need to focus on the two different branches of a star cycle. So once we've gone through the formation of a star and gone through a little bit of its life cycle, it's reaching the end of its days. It's a red giant now, and it'll soon begin to start collapsing. So it has two paths in which it can take, and it depends on the mass of the star itself. Before we go over to the black hole portion, we're going to go over the low mass star life cycle. So this is essentially what's going to happen to our sun because the sun is not a very big star. The sun, once it reaches its red giant stage, will begin to collapse in on itself. So the nuclear fusion that is happening inside of the star is the force that is pushing out and keeping the spherical shape of the star itself, right? However, the immense gravity of such a huge object is also imposing a force that is slowly crushing the star as much as it can. So when the star can no longer maintain a decent fusion process because of the heat that it produces, when it can no longer maintain a force that is stronger than the force of gravity acting upon it, the star begins to collapse, and eventually it will reach a breaking point and immediately just collapse in on itself like that. So when this happens, the star expels all of the outer layers that it has and becomes a white dwarf star. Now, the white dwarf star is extremely dense and and has a very large mass, similarly to a black hole. However, it did not have the mass to really collapse into a singularity. Now, singularity, I'll go over in just a second here. So the white dwarf star is now has a fission process instead of fusion. I'm not a chemistry major. I'll go so we'll go over nuclear fusion and nuclear fission maybe another time. So this process is slowly burning away all of the excess or leftover fuel that the star has in its core, right? So once that all burns away, it'll become a brown dwarf, and it'll essentially just be a giant rock floating through space. So now that we've gone over that branch, we can go over the branch of the actual black hole itself. So the black hole, when a star is large enough, it will have such a collapsing force strong enough that it will collapse into what is called a singularity. Now, the singularity is the actual black hole itself. It is the center of the black hole. Not much is really known about singularities, uh, considering the fact that we cannot see inside of a black hole. But they are extremely cool, extremely interesting, and they are very, very, very strong. So once the singularity happens, the black hole is now formed and it begins sucking in everything around it. It doesn't matter if it's a planet, comet, asteroid, another star, a star 50 times as big as the black hole, it will suck it in and keep it there. So now that we know what a black hole is, we can go over some interesting history about it, right? So the black hole was first theorized by Carl Schwarzschild in 1916. Now, if you remember the last name Schwarzschild, we said the Schwarzschild radius earlier. That's actually what it is. What it is named after. It is named after the first um, theorizer of black holes. Um, he theorized black holes mathematically, rather than actually theorizing them being out in space. He simply argued with his math that black holes could exist. Now we're going to go over just some fun facts. So we actually, every single galaxy, or at least most of them, has a black hole in the center of it of the galaxy. The Milky Way's black hole is called Sagittarius A, and it is a fairly big black hole. We call these supermassive black holes. These are the ones that keep the galaxy spinning, keep it running smoothly. Um, Andromeda, the closest galaxy to us, actually has a black hole as well. It's not named, but the area that it is in is named P2. Um, Now, something really fun is the biggest black hole ever found. So this black hole is called TON 618. This black hole is so extremely massive, we have to measure it in solar masses. So solar masses is one sun, is the mass of one sun, right? TON 618 is the mass of 6.6 times 10 to the 10th solar masses. I'm not going to go over how many zeros that is. It's a lot. It is extremely massive, and the radius of this black hole is actually the radius of the orbit of Jupiter. It is very, very, very big. So now that we've gone over what they are, how they're formed, and just some interesting fun facts about them, that is all I have today. What you see here actually is the first actual photograph of a black hole that has ever been taken. Um, this you guys might have seen this in the news sometime recently. This was an extremely important event in astronomy. So we've gone over what black holes are, how they're infinitely dense regions of space with an astronomical gravity that not even light can escape, how they're formed, how the life cycle of a star with a very big um, a very large mass star collapses in on itself and creates a singularity. And then just some interesting history about it, who first theorized it, the black hole's in the center of our galaxy and the biggest black hole ever found. Thank you so much. I appreciate you guys listening, and I will hopefully see you for next time.